Hi, welcome to this video. Today we are going to be looking at how to calculate the impurity of a particular split that we observe in a decision tree, specifically with Gini impurity. Let's start with an example. Now say we have 50 and 10, 50 belonging to one class and 10 data points belonging to another class. Then we have a split we are going to make based on a certain condition. So that will give us 30 data points in class 1, which is having 50 here in the parent node, and then say 7 data points belonging to class 2. In another split, we'll be having 20 data points belonging to class 1 and 3 points belonging to class 2. Now, let's start by examining or looking at the Gini index or the impurity measure in each node. So let's call this parent node. This is intermediate node 1 and this is intermediate node 2. The formula for Gini index is 1 minus sigma p square. P represents the probability of each class. Now let's look at the parent node and calculate the Gini index. So it is 1 minus 50 divided by 60 whole square. 60 is the total number of data points that is present in that node plus 10 divided by 60 whole square. This will give us a value of 0.278. Now this is the Gini index of the node. Now let's see what is the Gini index of intermediate node 1 and node 2. Just to reiterate, in intermediate node 1 is having 30 data points belonging to class 1 and 7 data points belonging to class 2. Similarly, for intermediate node 2, 20 data points class 1 and 3 data points for class 2. Intermediate node 1 Gini index will be 1 minus 30 by 37 whole square plus, let me zoom out a little bit, 7 divided by 37 whole square and sum of this thing. Now the value for this will be equal to 0. Properly 0.307. I have done a calculation for intermediate node 2 in the same procedure that we have followed for this. So for intermediate node 2, the Gini index will be 0.22. Let's try to understand how we can club all of these Gini indexes that we have calculated for 3 different nodes and see how it is getting utilized in the decision tree for building a better model or for having a better split in the decision tree. So we have 0.278, which is the Gini index of the parent node. We have 0.307, which is the Gini index of the first intermediary node, and the second intermediary node is 0.22. Let's just have it written here. As you can see, these are the 3 Gini indices. Now, the majority of the work that impurity measures are used for is calculating the amount of information gain. What we mean by that is the amount of homogeneity that we are able to get from a single split. To explain it using the decision tree that we have illustrated here, the Gini index says that we have 0.278 or 27.8% impurity. is 50 data points, 10 data points here, 30 and 7 and 20 and 3. So all of these numbers that we are seeing will help us mathematically represent those impurities. But for doing a procedure where we can calculate the information gain, it will be done as follows. So the split that we are getting should be or like a comprehensive value that can help us estimate the impurity gain of the split nodes or like the intermediate nodes is a weighted average of the Gini indices of the two nodes. In the first intermediary node, out of the 60 data points that were present in the parent node, 37 have come to the first intermediary node. So 37 out of 60 into 0.307 plus 23 or 23 data points belonging to second intermediary node, 23 into 0.22, which will be, let me just scroll down a bit, 0.273. Now to calculate the information gain, we need to subtract 0, the Gini index of the primary or the parent node, 0.278 with the number that we have got here, which is the weighted average, 0.273. So the information gain that we are going to have with these two numbers will be 0.005. Now, this tells us that there is a certain amount of information gain that is happening because of a certain split. So, if we look at this particular split alone, we'll be able to understand that this is what we are going to get. But there are multiple options or choices in which we can split the data set. Now, if we have instead of a condition that dictates this split, if we have another condition, we might end up with this split. There are 50 and 10 as similar to whatever we have in the original parent node, and we might have 30 and 5 and 20 and 5 instead of 30 and 7 and 20 and 3. So the information gain that we are going to get, or all the Gini indices that we are going to calculate for this split, will be completely different. So we ultimately want to consider a split that is having higher amount of information gain. Now, for example, for illustration purposes, let's say the information gain that we're going to get here is IG2. And let's put this value as IG1. We want to have a split which is having the greatest IG or information gain. If IG1 is greater than IG2, then this split will be considered. If IG2 is greater than IG1, then the above split, the alternative split that we have considered here, this would be chosen for further, to build the tree further down. So this is the crux of how we are going to use Gini index while building a decision tree. And I hope you were able to grasp the concepts properly. Thanks for watching.